10.4, starting section of the second part of chapter 10. We're talking more with perimeters, areas, similar figures in 10.4. Now, we'll kind of get into this more right here, but a scale factor is when you compare the lengths of two similar figures. We often write it as a ratio. If you have perimeter, now when you're thinking about this, perimeter is the distance around something. So we're looking at the distance around, that's still one-dimensional. Right here, this is one-dimensional. So that's taking the length and the width and making that into a ratio. Just like when we're looking at scale factors, these two are the same. Now when you're talking about area is when you're comparing the whole thing on the inside. Now when you're talking about area is always squared. So that means the area ratio is going to be squared. Those units and that number are squared. Best way to understand this is just getting into it. So for this first problem, it says that the scale factor is 6 to 8 or 3/4. Now, when you're writing the scale factor, you should make sure to always simplify your fraction. In this case, the first image is typically on top, the second image is on bottom. The first question is asking, what is the ratio of perimeters? Now, the first thing you have to do is figure out what the ratio is. Now, some people might think, but we don't have this side and we don't have this side. We can't find the perimeter. Well, when we're talking about the ratio, perimeter is one-dimensional. So because it's one-dimensional, we do not have to find the perimeter. It's still going to be one length compared to the other length, which is still going to be 3/4. Okay. Now, if we're finding the area, again, typically we would find the area and compare these two, and we'll get into problems that are like that. But because we only have the one length, as long as we know the perimeter ratio or their scale factor, which are the same, perimeter ratio, scale factor are the same, we can take that and we can square it. So my area ratio is my perimeter ratio squared. So in this case, it would be 9/16 would be my area ratio. So second one, I want you to try to do this one by yourself. Now this one said smaller to larger, so that's why the smaller is on top to larger. This one says larger to smaller. So I want you to try to answer these two questions right now by yourself. So because it said larger to smaller, my larger ratio is on top. And again, when I'm looking at similar polygons, the ratio of sides is the same thing as the perimeter ratio because it's one-dimensional. Here, this is two-dimensional, so that's why it's squared. So if I square 7, get 49, square 5, you get 25. So now we're going to actually get into using this information to help us solve equations. So it's already telling us that our area of the smaller hexagon is 1,273. So I'm going to write that inside my hexagon. It's asking what's the approximate area of the larger one. It's already telling us that these are similar figures. These are similar. So now I know my perimeter ratio. I often write out a chart, and you'll see me write this chart out. Notice how I have perimeter ratio, that's one-dimensional. Area ratio, I always write that as squared because we have to square this. So if I'm looking at my area ratio, this would be 49/100 because I'm squaring the top just like how we did up here and squaring the bottom. Because if we're going to be using area, which is squared, we have to use our area ratio. Now we can use this area ratio because this is how they're going to be comparable, the two areas. And because my area of the smaller one needs to be across my ratio of the smaller one right here, this is 1,273. We want to figure out the area of the larger. So you can only set up an area ratio with your area ratio. So if I were to solve this, I would multiply 49 times x, getting rid of that division. I would multiply by 100 and then divide by 49. So this estimated, it says approximate, so I'm going to round to the nearest tenth. It would be 2,597. Oops, actually that would round it up. And my feet squared. Feet squared. So the second question I want you to try to do yourself. First, though, remember you have to figure out your area ratio. When you're looking at a scale factor, that's your perimeter ratio. That's one-dimensional. So perimeter ratio is one-dimensional, area ratio is two-dimensional. So I have to figure out my area ratio. So you have to square the top and the bottom. This is the equation that you should be using to try to solve this. Remember, it says larger. That should be across from your larger ratio. So your equation should look like this. If your equation doesn't look like this, set it up like this, and now pause the video and finish solving. So the area of the smaller parallelogram would be 54 inches squared. That should be squared if you didn't notice. So 54 inches squared. So again, finding the area ratio to help us figure out the areas when we have similar figures. So this next question is applying area ratios to similar figures. It's already telling our scale factor. Scale factor is one-dimensional. So my scale factor, my perimeter ratio is 3 to 5. So I'm going to write that down, 3 to 5. Now it's talking about units of, talking about buying something. When you're buying something per unit. So this is actually in area. When you're talking about buying something that's two-dimensional, like a window glass is two-dimensional, this is per unit squared. Okay, so we need to figure out our area ratio. Remember, area ratio, we would square the top and we square the bottom. So it says the smaller cost $2.50. So when I'm writing up my ratio, $2.50 would go on top, and we want to figure out the price of the bottom. So we can use our area ratio now to try to find this price. I want you to pause the video and try to do the rest by yourself. So then that means that the larger one would cost around $6.94. $6.94. For the second one, this is a typical question that we might have in a quiz or test that might screw you up. Now, when you're talking about ratios comparing similar figures, you have to make sure you're comparing one to the other. I'm not using this as a ratio. It's giving me this 18 feet. It says with the larger dimension of 18 feet. So when I write up my perimeter ratio, comparing one to the other, this is the larger dimension in this room. So this would be 12 over 18. Those are my similar figures. I can simplify those. Those are both divisible by 6, so that would be 2/3. So now I can figure out my area ratio. Area ratio, if I square that, which would be 4 over 9. Now it's saying it costs $150 for the smaller room right here. So when I have my 4 over 9, my area ratio, $150 for my smaller room, and I have to figure out how much it would cost for a large room. So pause the video and continue to finish that problem. So for the larger room, it would be $337.50. Okay, it's telling you that the two images are similar right off the bat, saying these are similar. It says the area of the smaller one is 10 feet. So I know inside this would be 10 feet. I have enough information to figure out the area of this one. So 8 times 20 would give me 160 feet squared. It should be squared. So now what we have to figure out what this length is. What we have is enough information to figure out the perimeter ratio. Because right now, remember, perimeter ratio is always going to be one-dimensional. Area ratio is always two-dimensional. So this would be 10 over 160. We're comparing 10 to 160. If we simplify this fraction right here, I'm not actually doing anything with it. I'm simplifying the fraction. That's 1 over 16. Now, just like before, we took this number and squared it to get here. So we can take this number and square root it. We can actually take the square root of this number. We can do the square root of the top, which would be 1, the square root of bottom, which would be 4. So what this is telling me is that my smaller one, for every one length, it's actually 4 over here. So we can use this now to figure out my other side. 1 to 4 would be equal to, we don't know what x is, so that would be on top compared to 8. Now you can also do this in your head. You didn't have to set the equation. I want you to finish solving that right there. And that would be 2 feet. Again, I understand that some people can do that in their brain without setting up this equation. That's fine. So the second one is kind of similar. It gives you the area of two of them. I want you to pause the video and try to do this one by yourself.